Good morning, one and all. Myself Jagadish, Assistant Professor, Department of CSC, BITM, Bellary. So, as already we have started the topic called IPV4 addressing. In that, we have seen the introduction, classful addressing, classless addressing. Next is DHCP and network address translation. Okay. First, we have to discuss about the DHCP. So, what do you mean by DHCP? Dynamic Host Configuration Protocol. DHCP is nothing but Dynamic Host Configuration Protocol. Um, so, what is the use of this DHCP means? First, we need to have an idea how the static configuration of the protocol will be done. Usually, Bootstrap protocol will be used is a static configuration protocol. Each client has a permanent network connection. When a client requests a IP address, BootP server checks a table that matches the physical address of the client with its IP address. The binding is predefined. If the client moves from one network to another, then it creates a problem. BootP cannot handle these situations because of the binding between the physical and IP addresses is static and fixed in a table until changed by the system administrator. If there is a change in a physical or IP address, the administrator needs to manually enter the changes. So to remove the limitation of BootP, we are going for DHCP. Dynamic Host Configuration Protocol. DHCP does not require an administrator to add entry for each connection to the database. DHCP provides a mechanism that allows the computer to join a new network and obtain an IP address without manual intervention. The DHCP works like a plug and play network. DHCP provides a static and dynamic address allocation. Static addresses are created manually, whereas dynamic addresses are created automatically. Static address allocations. DHCP is a backward compatible with BootP, as I told already, which means a computer running the BootP client can request a static address from a DHCP server. A DHCP server has a database that statically binds physical addresses to IP address. Dynamic address allocation. So DHCP has a pool of available IP addresses. When a DHCP client requests a temporary IP address, the DHCP server goes to the pool of available IP addresses and assigns an IP address for a negotiable period of time. This is the introduction about DHCP. We'll see. After a block of addresses are assigned to an organization, the network administration can manually assign addresses to the individual hosts or routers. However, the address assignment is an organization can be done automatically using the DHCP, Dynamic Host Configuration Protocol. Usually, manually, statically, how we do it through the boot. DHCP is application layer program using the client server paradigm that actually helps the TCP/IP at the network layer. Here, the DHCP message format is given. You can observe some of the fields are given here: opcode, here operation code, request one or reply. So this will manage the whether what type of message it is, whether it is request or reply. Whereas H type, hardware type, whether it is a Ethernet or some other hardware. H length, length of the hardware address. The length of the address will be in this H count. Maximum number of hops that the packet can travel. Hops means I think you know number of hosts between a transmission path. Transaction ID, the integer set by client and mm, the integer set by the client to allow it to match up the request with the reply received from DHCP server. Whereas time elapsed, the number of seconds since the client started to boot. Flags. First bit defines a unicast 0 or multicast 1 and other 15 bits not used. Client IP address set to 0 if the client does not know it. Your IP address, the client IP address sent by the server, server IP address, a broadcast IP address if the client does not know it, gateway IP address, the address of the default router, server name, a 64-byte domain name of the server, boot file name, a 28-byte file name holding extra information, options, a 64-byte field with dual purpose described in next. This is the DHCP message format. Okay, here in this we need to know the purpose of the DHCP and the message format for the communication. Here we can see how exactly the option format will be used. So what actually the uh, DHCP message contains. Here you can observe it is a 53-bit tag and one bit length 1 bit. Uh, one is DHCP discover, uh, two is DHCP offer, three is DHCP request, DHCP decline, and five okay, in place of this one we can use any of the value 1, 2, 3, 4. We can use all these different 8 options. Yeah, DHCP pack, DHCP sorry, DHCP acknowledgement, DHCP negative acknowledgement, DHCP release, DHCP inform. All there are different formats. So what do you mean by DHCP discover? uh, DHCP discover is to discover the uh, we'll see that. uh, Always the DHCP client broadcast DHCP discover message on physical subnet to find DHCP servers. To find the DHCP servers, it will send your DHCP client will send a DHCP discover, and whereas DHCP offer, the client collects DHCP offer response from DHCP servers. The server offer an IP address, lease duration, etc. And DHCP request. Uh, so client sends a DHCP request message to the selected server. Whereas decline, DHCP decline is to decline the or decline or release the request. Whereas DHCP acknowledgement, client remains in the renewing state until one of two events happen. It can receive DHCP acknowledgement, which renews the release agreement. Whereas DHCP NACK, the client remains in the rebinding state until one of three events happens. If the client receives DHCP NACK or lease expire, it goes back to the initializing state and tries to get another IP address. And DHCP release, DHCP, if the client is no longer needed an IP address, then it sends a DHCP release a message to the server. And DHCP inform, DHCP inform um, is to inform to the client. So these are all the different 8 values we can use in the message in the DHCP communication. Yeah, this is how the DHCP will work. We can observe. Yeah, this is a DHCP discover message to the from client to the server. Here, what all the information this DHCP discover is containing: transaction ID, lease time, client address, your address, server address, as already we discussed, source port, destination port, source address, destination address. All these are all there in the DHCP IP address of the server. So the request goes to the this one. Whereas a server will offer a or it will send a response for the sent discover request. So it is sending back the response. DHCP offer transaction ID 1001, lease time 3600, client address, server address, source port, destination port, source address, destination address. It will send the offer message. Whereas once again DHCP request um, DHCP request message will be sent. So this DHCP request message is nothing but mm, um, the client must choose one of the offers and negotiate with the server for a lease. To do so, the client sends DHCP request message to the selected server. So once again, the client will send a DHCP request to the DHCP server. This is how this particular DHCP will work in performing the operation. Whereas for the send request, the DHCP server will send the positive acknowledgement as DHCP acknowledgement. So in this transaction ID is there, lease time is there, client address, your address, server address, source port, source address, destination address, all this information is available for a requested to a legend. This will work in application layer, UDP layer, IP layer. Not only partial information is given, complete information is not given here. So this is a finite state machine for the DHCP client. How exactly the DHCP will work, uh, that will be shown with the help of finite state machine. When a DHCP client first boot, it enters the init state. You can observe here. Um, uh, it has no IP and does not even know where a DHCP server may be on the network. That those are all not known. So DHCP client broadcasts a DHCP discover message on the physical subnet to find DHCP server. This message is in the form of a UDP packet and usually at least contain the client MAC address in option section. This is next one. Selecting state. This is selecting state. After sending a DHCP discover message, the client goes to the selecting state. In this state, the client collects a DHCP offer response from the DHCP servers. Here, this one. Um, Response from the DHCP servers that the servers offer an IP address, lease duration, etc. The client must choose one of the offers and negotiate with the client for a lease. To do so, the client sends DHCP request message to the selected service. It can offer, sometimes it can negative acknowledgement also can send it. Request state. Mm, In the requesting state, the client remains in the requesting state until it receives a DHCP acknowledgement message from the server that creates a binding between the client physical address and the IP address. After receipt of the DHCP acknowledgement, the client goes to the bound state. Here, this one, bound state. The bound state. In this state, the client can use IP address until its the lease expires. Lease expires. When 50% of the lease period is reached, the client sends another DHCP request to ask for renewal. It then goes to the renewing state. When in the bound state, the client can also cancel the lease and go to the initializing state. Renewing state. Renewing state. Here you can observe this is a renewing state. The client remains in the renewing state until one of two events happen. It can receive a DHCP acknowledge which renews the lease agreement. In this case, the client resets its timer and goes back to bound state. Or if the SCP pack is not received and the 87.5% of the lease time expired, the client goes to the binding state, rebinding state. This one, rebinding state. The client remains in the rebinding state until one of three events happen. If the client receives a DHCP negative acknowledgement or release expires, it goes back to the initializing state and tries to get another IP address. If the client receives a DHCP pack, it goes to the bound state and resets the timer. Early release. This is the explanation. If the client is no longer needed the IP address, then it sends a DHCP release. You can also DHCP release message to the server. The server accepts the request and assigns IP address to another client waiting for the address. So this is about the uh, FSM finite state machine for the DHCP client. So in this, we will get the exact procedure or exact steps how the DHCP client will follow to get the response from the DHCP server. So this completes the topic DHCP, Dynamic Host Configuration Protocol. So next, in this, we will see network address translation. In most situations, what is this network address translation? Why it is required? In most situations, only a portion of a computer in a small network needs access to the internet simultaneously. A technology that can provide the mapping between the private and the universal address and at the same time support virtual private network. Network address translation, the technology allows a site to use a set of private addresses for internal communication and a set of global internet addresses for communication with the rest of the world. So some more points we will see in this. That is within a company. Okay, before doing that one, we need to understand. Within an example, within a company, every machine has a unique address of the firm in a dotted decimal format. When a packet leaves the company premises, it passes through the network box (NAT) network address translation box that convert the internal IP source address. NAT box is often combined in a single device with a firewall. It is also possible to integrate network address translation box into the company router. We will see that how exactly NAT will work. Here, this is the NAT router, network address translation router. You can observe these are all the local IP addresses 172.18.18.3.1. In this way, sequentially, the IP addresses are assigned till 20. And here, this is the IP address 172.18.3.30. And after converting this IP address, it will become 200.24.5.8, and this will become a global address line for internet communication. Here, how exactly the address translation is done, you can observe 172.18.3.1. Uh, Here, this will be converted as a 200.24.5.8. You can observe source address. This is what 172.18.3.1. This is converted as this address here. This is converted as to and source address. This is the source. In this example, this is the source. This is converted as 200.24.5.8. Local address, private addresses are converted as global addresses. You can have the destination address 200.24.5.8. So this same address we are using here because this internet will think this particular address as a destination address. Actually, this is not the actual destination address. This 200.24.5.8 should be converted as 172.18.3.1. This we will see here. This address act like a source from this side, whereas this act like a okay. This actual private address is converted as uh, global address and it reaches to the destination, and from the destination this will destination side will become the source. So and this will become a destination like so. This is converted um, address from actual private address to global address, that is 200 dot 24.5.8. This is once again converted as the original as 172.18.3.1 with the help of this NAT box, network address translation. Let's go on. This is the translation. How exactly the translation is done in the communication? You can observe actual. There are um, different networks here. This is private network. This is a private network. This is containing the um, this is one node, and sorry, this is the table here also. This is the table you can observe. Source address is 172.18.3.1. Destination address is okay, same uh, 25.8.2.10. This is the source and this is the destination. Here, how it reaches to the destination, you can observe. Source address, destination. One, make a table entry. Here, this table entry is done. These two address, source address and destination address is taken. It has been done. So 172.18.3.1 is source address. It is in. It is a private address. Whereas the destination address is 25.8.2.10. This is the universal address. uh, First made the entry. Second step is change source address. Here source address is changed as so private source address is changed as universal source address, that is 172.18.3.1 is changed as 200.24.5.8. That is will be done in second step. Whereas the third step, access table. Here at the destination side it accesses the table because it should know uh, uh, which is the source and which is the destination. This is the destination, this is the source. Here, mm, in this is the source address. For this, we have the actual source address. This is the destination address, and finally, change the destination address here. Destination address is changed here. So conversion is done actually. 25.8.2.10 is the actual uh, universal address that should be changed as private address here. So vice versa should be done. So in this way, the translation of the source address to the destination address to source address will be done between the private address and the universal address. So this is how the five column table translation table is maintained in NAT network address translation. Here private address will be having private port, external port, and transport protocol. Which protocol is here? This completes the topic IPv4 addressing. In this IPv4 addressing, we have discussed about the introduction of IPv4 addressing, then um, classless addressing, classful addressing, then DHCP, dynamic host configuration protocol, and the NAT functionalities. So all of you go through this video and understand and reply for the assignment.